Bismillahirrahmanirrahim. This is Fayaz Munchandio, chemistry teacher. In the previous lecture, we completed chapter number 5, the physical states of matter. Now we start chapter number 6, solutions in grade 9. Solution is a homogeneous mixture of two or more than two substances. The solution is a homogeneous mixture of two or more than two substances is called a solution. Now, students, solution has two components: solute minor quantity present in a solution is called solute, and other one is solvent. Major quantity present in a solution is called solvent. So when the solute mixes with the solvent, you will get a solution. Examples: if we are dissolving salt plus water, salt is a minor quantity, small quantity, water is a large quantity, so salt is a solute and water is a solvent. So when the salt, sugar, alcohol dissolve in water, so this is a solute and this is a solvent. When they are going to mix with each other with a uniform composition, a single phase comes, this is called a solution. Now, students, when we are talking about a solution, the homogeneous mixture, so when we are talking about the water solvent, we call it an aqueous solution. When we use water as a solvent, then the solution is called an aqueous solution. Aqua, Greek word. Aqua means water. That's why the solution of water is called aqueous solution. So salt plus water is aqueous solution. Sugar plus water is also called a aqueous solution. So again I am telling you, solution is a homogeneous mixture of solute and solvent to make a uniform composition. One state, one form you will get. Example I gave you, minor quantity is called solute and major quantity is called solvent. So solute and solvent to make a solution, and when you are dissolving solute in a water, then the name of solution is called aqueous solution. So this is aqueous solution we have. Now when you are making solutions, they have different points. While you are making solutions, then you have a unsaturated solution. In unsaturated solution, you have a, suppose this is a container beaker and this container contains about 50 centimeter cube of water. So this is a solvent. So when you dissolve 5 grams of sugar. So when you dissolve, this is a stirrer. By stirring it is going to be completely dissolved in water. So when you take a 50 centimeter cube of water in a beaker and you are dissolving 5 grams of sugar, so when this sugar dissolves, when the sugar dissolves in water, and again this solute can dissolve in a solvent to make a solution, this is called unsaturated solution. In other words, I can explain that the solution which has more ability to dissolve solute in a solution at a particular temperature is called unsaturated solution. Means the solution which has still ability for dissolving. More solute you can dissolve in a solution is called unsaturated solution. Again I am telling you, take a 50 centimeter cube, you can take a 100 also, no problem. Then dissolve 5 grams of the sugar or salt solute. If you dissolve and you can dissolve more, means this solution has ability to dissolve more solute at that temperature. Temperature is very important. At a particular temperature, suppose your lab temperature is 25 degrees centigrade, so maintain this temperature. So at this temperature, when the solute dissolves in a solution is called unsaturated solution. So this is one thing. I think you understand. The other one is saturated solution. Saturated solution. The saturated solution is, you have again 50 centimeter cube of water, solvent in a beaker, and you are dissolving 5 grams of sugar, and now you are making double 10 grams and stirring it. The point will reach where the solute particles settle down. This solute particle settle down. This solution has not ability, unable to dissolve more solute at same temperature is called saturated solution. The solution which has not ability, unable to dissolve more solute in a solution at a particular temperature is called saturated solution. Example I gave you. Take a 50 centimeter cube of water in a beaker and add the solute, stir by stirring it, it dissolves. Add more and stir again, it can dissolve. So keep on dissolving till the solute will settle at the bottom of the container, bottom of the beaker. So it means that this solution has not ability to dissolve more solute at a particular temperature is called saturated solution. So this is a saturated solution. Now there is another one which is called supersaturated solution. Supersaturated solution. So when you make the saturated solution, when we make a saturated solution at a particular temperature, then we heat it. We heat. When you heat the solution, the kinetic energy of the solvent particles is going to be increased and solubility of the solution is going to be increased also. So when a saturated solution is heated at a particular temperature, the solution has more ability to dissolve a solute at that temperature is called supersaturated solution. Again, I am telling you, it is very important to mention or maintain the temperature. It means that according to the instruction of your teacher in the laboratory, at what temperature you are preparing the solution, that temperature you have to mention. So if you prepare the solution at 25 degrees centigrade, this was saturated solution. Now you are heating, suppose instruction from your teacher, please prepare the supersaturated solution at 40 degrees Celsius. So by using thermometer, heat the saturated solution, add more solute. So when the temperature reaches 40 degrees Celsius and more solute dissolve in a solvent to make a solution, this is called a supersaturated solution at 40 degrees Celsius. I think it's clear for you. Next thing is that this supersaturated solution is unstable. This is unstable solution. Means you can't maintain forever 40 degrees Celsius. No, we can't keep burning or 45 degrees Celsius. No. So it means that when we off the burner, we take out the burner, we stop heating, then the kinetic energy of the particles of solvent decreases and the solute you put extra in a solution which accumulate, collect, and again it will settle down to make a crystallization. This is a crystallization. You will get extra solute at the bottom of the container. This is a crystallization formation. Again, I am telling you that when you are adding more solute by increasing a temperature at the particular temperature, the more solute dissolved in a solution is called supersaturated solution. It is unstable because we can't maintain the temperature. So that is why when we are taking out the burner, again cooling process taking place, the extra solute you add in a solution will settle down here and you will get the solute here. So the crystal of the solute taking place and this process is called crystallization and you will get again a saturated solution. Now there is a one activity in your book. In your book there is a one activity, if you see chapter number 6, sodium thiosulfate crystals. Sodium thiosulfate is a salt. It can dissolve sodium thiosulfate. If you have formula, this is the formula of sodium thiosulfate. Very beautiful long needle-like crystals of sodium thiosulfate are here. So there the one activity in your book, the diagrams you can see from the book, there is a given here. Now how we identify that solution is saturated or super saturated? So when you have a saturated solution and if you drop a crystal, if you are dropping a crystal of sodium thiosulfate, so if it will stay, if this crystal stay in the test tube, this is called a saturated solution. And if you are going to dropping a crystal in a solution and you will get a huge precipitation, crystallization. If there is a crystallization, if you see your book diagram is given, if there is a crystallization, this means that this is a supersaturated solution and this is a saturated solution. In your book, this diagram is given. So how we differentiate saturated solution and also supersaturated solution. So there is a one assignment, self-assessment exercise 6.1. If you see your book, chapter number 6, again I am telling you, self-assessment, I think it's clear for you. Self-assessment exercise 6.1, chapter number 6. Now I am going to read. It's very careful, please read. You have to understand very well this one. He said that the maximum amount of sodium acetate, because we are chemistry students, so we should know the formula of the compounds. CH3, COO and A. This is the formula of sodium acetate. This is a salt. So we have a sodium acetate salt, and written here in the question, you are dissolving 100 grams of solvent taking 100 grams. You are maintaining 0 degrees centigrade and sodium acetate dissolve 119 grams. So students, 100 grams of water, 100 grams of water, maintaining temperature 0 degrees Celsius, and sodium acetate dissolves 119 grams. So at 0 degrees Celsius, in 100 grams of water, the sodium acetate solute salt dissolve 119 grams. This is the one thing very important, you have to remember it. Another one, now you are maintaining 100 degrees Celsius now, not 0, 100, and sodium acetate dissolve 170 grams. So at 0 degrees Celsius, sodium acetate dissolve 190 grams, and at 100 degrees Celsius, sodium acetate dissolve 170 grams, keeping the solvent 100 grams. This is a statement which is given in the book. Now questions he asked. Question number A. Very careful when you see my lecture, please open the book and you have to give the answers, and also I am explaining what are the answers for these questions. Question number A. He said that if you add 170 grams of sodium acetate, 170 grams sodium acetate in 100 grams of water, but the temperature he says 0 degrees Celsius. Again I am explaining 100 grams of water, 170 grams of sodium acetate. Temperature is 0 degrees Celsius. Then the question is that how many grams of sodium acetate dissolve? So it is very simple. These answers are given, these hints are given you that at 0 degrees centigrade only 119. So the answer is, if you are maintaining 0 degrees Celsius and you are dissolving 170 grams, so students, viewers, only 119 grams will dissolve, because you are making 0 degrees Celsius. So the answer is at 0 degrees Celsius, so only 119 grams of sodium acetate will dissolve and other will settle at the bottom of the container to make a saturated solution. So this is the answer of A. You can see also book. B is the solution is a saturated or supersaturated. So as I explained in the previous topic, means saturated solution, and I told you that the solution which has not ability to dissolve more solute at a particular temperature, so this is saturated. This solution is saturated because you are adding 170 and only 119 dissolve. The remaining will settle down the bottom. So your answer is saturated. The solution is a saturated solution. This is the B answer. Answer number C. If the solution is heated 100 degrees centigrade, this one. If the solution is heated 100 degrees Celsius, is the solution now saturated, unsaturated, or supersaturated? So I told you, this is written already here, if you heat a saturated solution and the solute more dissolved at a particular temperature, and that temperature means we are maintaining 100 degrees Celsius, the solute more dissolved, so the answer in the solution is a supersaturated. So the answer for the question number C is supersaturated. Number D. If the solution is cooled back, when you maintain 100 degrees Celsius and 170 grams dissolve, now he said that when you cooling back at 0 degrees centigrade. Cooling back and 0 degrees centigrade, so no crystals appear, there is no crystallization, nothing will be happening. The question is now, if the solution is saturated, unsaturated, or supersaturated solution. So viewers and students, I am telling you that when you add a solute in a solution, so when it completely dissolves, no crystallization taking place, no precipitation taking place, the solution is unsaturated. The solution is called unsaturated. So this solution is called unsaturated solution. Now we are talking about solutions. Types of solutions. Types of solutions. Now students, then one very important point I want to revise you. When you are making solution, the very important rules of solubility. Only one introduction. This is extra information for you because we are making solutions. One rule. Like, dissolves like. is very important. This is the rule of resolution, making solution like dissolve like. So there are two, we have types of the liquids or compounds: polar ionic, non-polar. Polar compounds, polar substances, covalent. What is a hybrid polar? Ethanol is a polar, sugar is a polar, glucose is polar, ammonia is polar. There are many examples. Covalent compounds I am talking about. Ionic compounds: sodium chloride, copper sulfate, potassium nitrate, sodium thiosulfate, sodium chloride, potassium chloride. These are the ionic compounds. I am not going to go the detail for these. Non-polar, they have no partial positive and partial negative charges. Non-polar, benzene, very example, good example for the non-polar compounds. Benzene, carbon tetrachloride, oils, grease, these are the non-polar. So when we use this rule, like dissolves like, polar solutes dissolve in polar solvents. Alcohol polar dissolve in water. Acetic acid polar dissolve in water. Glucose dissolve in water. Sugar dissolve in water. Polar dissolve in polar. Ionic compounds also dissolve in polar. Sodium chloride ionic dissolve in water. Potassium nitrate ionic dissolve in water. So these are the like and like. Non-polar dissolve in non-polar. Grease, petrol, benzene. Grease is non-polar, petrol non-polar, grease non-polar. Benzene non-polar. So they are going to dissolve with each other to make solution, homogeneous. But when you dissolve polar in non-polar, there will be no solution formation. Just like you put oil in water, oil density less floats on the surface of water. It does not dissolve. So non-polar dissolve in non-polar only. Polar and ionic dissolve in polar. So that's why the rule is like dissolves like. So this is a very important information I am giving you. So mind it that always like solutes dissolve in like solvents. Now, types of solutions. In the types of solutions, we have three main types. Three main types of solutions. Number one, gas. Number two, liquid. Number three, solid. Gas solutions, liquid solutions, and solid solutions. So now before I am going to explain these, again I am going to tell you that when you making the solution, it should be a homogeneous mixture. Homogeneous. You done in the chapter number 1 the homogeneous and heterogeneous. In homogeneous, there will be a uniform composition. Only you will get a one state of the solution, which is a solvent. It means that when you dissolve a solute in a solution, so only the one phase will come, that is a solvent phase. Completely homogenize, dissolve. And in the chapter number 1, you done the heterogeneous, means the solute particles you can see by your naked eyes. Just like you are putting the salt in sand, you can see the solute particles in a solvent.